In this lesson, we're going to look at how to solve quadratic equations using the square root method. So just a quick review of radical expressions. A radical expression, remember, is something with square root, cube root, etc. The radical symbol looks like this. And just as a note, sometimes there's a number there. If there's a number there, that number is called the index. Don't see a number, it's a square root. Do see a number, it's another root. This is cube root, for example. When we're looking for the simplified version of a square root, we're looking for numbers that have a factor appearing twice. So first thing you need to make sure you understand is, what is a perfect square? So 1 squared is 1. The next perfect square would be 4, 9, 16, 25, 36, 49, 64, 81, 100. 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, and there you have it. So it's just kind of making sure we're familiar with them. Okay, now let's look at actually simplifying. So the first thing is make sure that if it's perfect square, all you're doing is looking for the number times itself. That gives us that value underneath the radical. If it's a non-perfect square, we have to do something called simplifying. So when we're simplifying, we want to break the radical down using large perfect squares. So that means we're going to basically do factor trees. Kind of helps us with this. We take the square root of any perfect square factors, and then we have the leftovers under the radicand. Couple things to note. Fractions. We never, ever, ever leave a radical in the denominator. And we'll take care of that in a little bit. Okay, let's do just a couple practice things. Okay, so let's do an easy one. Square root of 49. 49 is on our list, so that tells us that the square root of 49 is whatever times itself makes 49, and that would be 7. Now let's look at number 6. Okay, so it's the square root of fractions. So when we have fractions, it's the square root of the numerator over the square root of the denominator, and then we simplify each individually. 36 square root is 6. 121 square root is 11. Okay, let's look at number 8. 245, not a perfect square. So what I'm going to do for number 8 is I'm going to take 245 and I'm going to break it down. Using my divisibility rules, I know that 5 goes into this, and 5 goes into 245. (49) times. As soon as I see I have that perfect square, and this is, and my other factor is not a perfect square and can't be broken down anymore, I know that this is really the square root of 49 times 5. The square root of 49 times the square root of 5 is how we can break it down, which means square root of 49 is 7. Square root of 5 is just the square root of 5. And there's our simplified version. Okay, and then let's just do one more. We'll do number 12. Do it up here. Okay, so it says 3 times the square root of 578. So I'm going to take 578. I'm going to break it down by factoring it. And suppose this is such a big number, the only thing I know about it is it's even. So I'm going to go ahead and say it's 2 times what? So it'll be 2 times 289. And 289, maybe I don't remember at the moment that it is a perfect square, but it is. So I go in and think about what numbers multiply to make 289, and I realize, oh my gosh, it's 17 times 17, which makes it a perfect square. So that means I have the square root of 2 times the square root of 289, and 3 square root of 2 can't be simplified. 289 is the same as 17. So any factors outside of the perfect square I multiply together. So that's going to make 51. And then whatever is left under the radical, I write next to it. Okay, so let's go ahead and start with actually solving. Okay, so we're going to use the square root method. So the reason you would ever use this method, okay, is when you have a radical equation that's of the form ax squared plus c equals 0. So it's not going to have a linear term. Okay, so if this is true, what we can always do is we solve for x. And as soon as we go ahead and solve for x squared, we'll end up with square root, or x squared equals number. Then we take the square root of both sides. So we always, and you have to remember two things. Whenever I take the square root of something that's squared, that's an unknown, I don't know if this number that was squared was negative or if it was positive. Because negative 5 squared is the same as 5 squared because they're both equal to 25. So when we go ahead and we do square root of x squared, we got to remember that we could have two solutions. The positive root or the negative root of whatever the square root of that number is. So our steps are isolate the x squared, take the square root of both sides, simplify the radical, and make sure we include plus or minus. Okay, let's do a couple problems. So let's look at this one. To get x squared by itself, so I'm going to subtract 8 from both sides, which gives me 7. Then I would divide both sides by 7, giving me x squared is 1. And now I'm going to take the square root of both sides, remembering to do plus or minus as soon as I do that. So I get x is positive or negative 1. And if I go back and check, and I put in a 1, I get 1 squared is 1, 7 times 1 is 7, plus 8 is 15. And if I put in a negative 1 and I square it, I also get a positive 1, which gives me 7 plus 8, which is 15. Okay, let's go down over here to number 7. I'm going to do it up here. So, and I go ahead first, and remember I'm trying to isolate the x. So I need to subtract 4 from both sides. So I get negative 3x squared is negative 81. And now I'm going to divide both sides by negative 3. So that gives me x squared is positive 27. Once I've isolated x squared, I'm ready to take the square root of both sides. And when I do that, remember, I got to do plus or minus. So I get x is plus or minus the square root of 27, which I have to break down. 27 is not a perfect square. I know that it's 9 times 3, and 3 times 3 makes 9. In case you forgot, 9 is a perfect square, but remember, another way to think about simplifying radicals is you're looking for numbers that appear twice as a factor. So they come out, 3 stays under. So I get x is plus or minus 3 square root of 3. One more, number 9, just because it has a fraction in it. Know how much you like fractions. So first thing we're going to do is we're going to go ahead and we're going to subtract 1 from both sides. So that gives me negative 40. negative 1/2 x squared equals negative 40. And then I go ahead and I divide both sides by negative 1/2, which is the same as multiplying by negative 2, which gives me positive 80. Now I'm ready to do the square root of both sides, remembering plus or minus, and I'm going to break down the 80. I have 8 times 10, not a perfect square. 8